in this video, we're going to look at the equations of semicircles. It's a follow-up to the previous video on the equations of circles. Within the equation of a circle, you typically would have 4 possible semicircles: top half, bottom half, left half, and right half. And all you really need to do is take that standard equation that we've looked at in the last video, if you watched that. If you haven't, as a reminder, x minus h squared plus y minus k squared equals r squared, where h comma k is the center of the circle and r is its radius. If we take that and solve for individual variables x and y, we will get the individual semicircles. Now, if we think about the top half, bottom half semicircles, and we typically think of top and bottom being vertical in nature. The y variable is our vertical variable. Its axis goes vertically. It's up and down when we count and plot points and stuff like that. So here, if we're going to find the top half or the bottom half, we simply start by solve for y in each particular case. If you take this equation, solve for y, you're going to get the top half or the bottom half. Now you'll notice that the equation that we have, the standard, is quadratic in nature. At some point, we are going to need to take a square root. So when we do that, we end up with plus or minus the square root. Now, to separate the top half from the bottom half, you just take the particular root. The top half would have the larger y coordinates, so we're going to keep the positive square root. The bottom half is going to have the smaller y coordinates, so we'll take the negative square root. And so those will give us the two vertical halves, the top half or the bottom half. Now, we'll do a similar thing for left half and right half, that what we would start by solving for x in each case, being that the x variable, the x-axis is our horizontal axis, and we're talking left and right here, so we're thinking horizontal in nature. Pardon the bell in my room. And then once again, we would have a square root because we have to undo the quadratic nature of this. What we would do here is, once again, we think larger and smaller. The left half on the graph, x coordinates to the left are the smaller coordinates. So the left half is going to be solve for x, keep the negative square root. And the right half, where our x coordinates are larger, are going to be solve for x, keep the positive square root. So hopefully you can make an association between the procedures and why we're doing that procedures based on left, right, top, bottom, x's versus y's, horizontal versus verticals, as well as larger or smaller coordinates being associated with positive square roots or negative square roots. What we're going to do now is just a couple of examples to show what that might look like. So starting with a fairly easy equation, letting this equation be centered at the origin. It's x squared plus y squared. There's no value for h. There's no value for k for the zeros. And a radius of 9. We have an 81 there. That constant is the radius squared, so the radius would be 9. So if I take my semicircles, and let's say I want to start with my top and bottom halves, I would take the equation x squared plus y squared equals 81. Rewrite as y squared equals 81 minus x squared. And then take the square root of both sides, remembering that when I take the square root, I get plus or minus. 81 minus x squared. Now, all it's required to do from here is to separate that amount. That y equals the positive square root of 81 minus x squared is going to be the top semicircle, and that y equals the negative square root of 81 minus x squared is going to be the bottom semicircle. Just abbreviate that there. And for the left half, right half, it would be very similar. If you want to pause the video, try it yourself. It might not be a bad idea. Come back and look at the solution. Okay, if you're back, and I want to find the left and right halves of my semicircles. I'm going to take my equation x squared plus y squared equals 81 and solve for x, my horizontal variable. X squared equals 81 minus y squared. X equals the plus or minus the square root of 81 minus y squared. And then just separate them out. That x equals square root of 81 minus y squared. I've got the larger values here, the positive square root. On the coordinate plane, larger values of x are to the right. So this is going to give me my right semicircle. If I separate it out, and I have the negative square root, those are going to be smaller values of x. On the coordinate plane, smaller values of x are to the left. And so now we've got our left half and our right half. Okay. And that's generally the procedure. But that problem was a little bit contrived and a little bit easy. But what if we had something that looks more like the standard equation, where our center is not at the origin? We've got this x minus 1 squared. We've got a y plus 2 squared. We've got our 81. How are we going to handle that? Well, and this might go against some of the things you ever heard. We're actually not going to expand out. We're not going to simplify. We're actually going to leave some things as is so that we can retain our information. We will still be able to tell what the center and the radius are. So once again, why don't we start with the top and the bottom, which means we're going to start by solving for y. So if I solve for y, what I'm going to do is I'm going to simply start by moving the entire set of parentheses, x minus 1 squared, over to the other side. I'm just going to subtract it from both sides, move it to the other side. I'm not going to expand it out. I'm not going to do any distributing. I'm just going to leave it as is. And then to start getting at the y, I'm going to eliminate the squared on y plus 2 squared by simply taking the square root of both sides. And once again, I'm not going to expand anything out. I'm just going to leave it as is.
Walter, please report to the chorus room.
Sorry about that. So where were we? We were solving for y. I took the square root of both sides, plus or minus. I did not expand anything out. That way I'm keeping my 81, so I know that my radius is 9. I'm keeping my x minus 1 so that I know that the x coordinate of the center is 1. Then I will subtract the y. Excuse me. I'm going to subtract 2 from both sides, so I have y equals negative 2. Apologies for all the bells there. So we are solving for y. I subtracted 2 from both sides. And I end up with 81 minus. And once again, don't expand it out. If we expand it out, it's like that alternate form of the circle where we lose meanings. Here, I still get to retain the fact that this is r squared, that this is my value of h. Now, but in this particular case, now because I moved it to the opposite side, I've got the opposite of k there. But I still am able to retain the values for my center and the value for my radius. So then, like I showed in the previous example, the top half of this semicircle would be the negative 2 plus the square root expression, and the bottom half would be y equals negative 2 minus the square root expression. All right? So that's top and bottom. And then for the right half and the left half, it would follow similarly. If you want to take a moment, pause the video, maybe try it yourself. You can come back and I'll put up the solution. All right, so if you're back, remember the equation was x minus 1 squared plus y plus 2 squared equals 81. And if I'm going to go right and left semicircles, I'm going to solve for x. I'm going to start by moving all of my y's to the other side without expanding or simplifying, so I can retain the 2 as my y coordinate of the center. I'm going to take the square root of both sides. And then I'm going to add 1 to both sides. If I leave it as this, the equation I have right now is for both the left half and the right half. Remember, though, that if I want to separate them out individually, the right half is going to have the larger x coordinates, so that gets the positive square root. And the left half is going to have the minus the square root, because it has the smaller x coordinates. Once again, also remembering that here we still are retaining our radius squared, that we are retaining our value of k, that's the y coordinate of the center. In this case over here, we do have to be careful. This is no longer the x coordinate of our center. It is the opposite of the x coordinate because we changed sides and we added it to both sides. Okay, so I hope that helped. Pardon the announcements and Bell's interruptions as I was recording this in school, but I hope you found this at least a first step on being able to work with the equations of semicircles.